Today is February 12th, 2025. My name is Justin Murillo, and today we are going to be discussing FTT 122 assignment 541 or class 54148, and this is our week 6 assignment in which we start to discuss trajectory, sights, gyroscopic drift, drag, Magnus effect, a couple other effects that I can't pronounce, and vertical angles. And then transonic ballistic performance as well. Right, so we're going to go ahead and refer to our textbook, page 224 of Introduction to Ballistics and Ammunition by SDI. And on there we see our first topic, trajectory and sights. Most shooters believe that the projectile, when it fires, it rises as soon as it exits the barrel and then comes down. But we already know that's not true, simply due to the fact that gravity has a major impact on that as soon as the round comes out. So if I were to throw, let's just say, this screwdriver here, it's not going to go straight right away. It's going to start to decline, and it's going to start to follow the curvature of the Earth. Now, as the projectile follows its line of departure, it will eventually intersect the line of sight. So let's just go with, actually, we'll do that. And then we'll say that this piece of paper is our point of impact. So if we have a marker, which I do not, we'll just say this green dot is our point of aim. Now, as our round is leaving the barrel, it eventually starts to fall. Now, the thing about sights is you want to adjust those to be able to bring that up so that your round is able to point of aim, point of impact, and that is known as point of zero. Now, next up, we have the gyroscopic effect. Or drift, sorry. And this is kind of a weird phenomenon that happens or occurs when applying force to a spinning object. Think of it like when you're throwing a football. Instead of the object moving in a line of your directional force, the spinning object will move perpendicular to the direction of force. And then it'll be moving in the direction of its rotation as well. So if you have a baseball, right, and you give it a slight, twist with your little right twist, it will spin to the right, but it'll also somewhat curve. There's actually a movie that relies heavier on this, and it's kind of one of those like assassin movies where the lady, she's trying to spin the round or whatever, and that there is complete bullshit. No, not possible. Anyways, the force of gravity is pulling down on the projectile, and it spins clockwise to create a slight yaw of repose, which forces its rotational axis to point slightly to the right. Now, for the next topic, we're going to kind of be talking about drag, right? And there are multiple ways of calculating drag, which I don't think I have to do in this video just yet. I just have to discuss it. So basically, drag is when, think about on a motorcycle, right? You come up behind a truck, we're talking about semi, and you are feeling all that air coming off the truck, and it's just kind of pulling you wherever that air wants to go. Same thing with a round. As a round is in trajectory, you get all this buffeting, and now your atmosphere is affecting that as well, and problem is that drag can be unstable. But there are different ways to calculate drag so that you can have your point of aim, point of impact. As we discuss the rotational force in which rounds are going, there's another example that I would like to kind of go over. So, as we know, in the northern hemisphere, if you go to flush your toilet, it's going to spin to the right. But in the southern hemisphere, it spins to the left, right? Everything rotates to the left. Now, and this is weird, but basically you're moving on the path of a ball while it's in the air. This is a invisible force that appears to deflect the wind, but it's known as the Coriolis effect. And like I just said, this affects to rotating objects, so football, flushing a toilet, and as well as ammunition. Before I discuss the Coriolis effect, I would also like to dip in on the Magnus effect. So in baseball, a pitcher's top spin on the ball causes the ball to spin downward. Or in soccer, kicking the ball underneath or to the side will cause it to curve. And the way this works is as the object spins, it drags some of the air around it. And this is one of this is actually Newton's third law. This creates a pressure difference between the top and bottom of the object. So if you go to hit an object and it starts spinning one way, that airflow on the other side is going to start pushing it, and it's going to keep going. Now, as we discuss the Eötvös effect, the way I'm understanding it is basically if you take a cannon and place it onto the equator, right, and fire it straight south. Now, instead of hitting the South Pole, it's not going to do that. The Earth is rotating at about 1,000 miles an hour, a little bit over that. So you are going to end up way off. Now, if that cannon was zeroed, that might be where your sights and your trajectory are going to come into play. And also your vertical angles, which is something that we're going to dip on here in a second. High school, we were thinking, some people ended up going to trigonometry. Myself, I was only in algebra. Cool deal. Whoop-de-doo. Go through the bare minimum. Cool. Now those who went through trigonometry, geometry, stuff like that, they might actually be able to do vertical angles in the hunting application a lot better than I would be able to do only having algebra experience. Now, with that being said, think about you trying to fire on a animal that is placed way uphill and you are down in the valley, right? Now you are shooting at an angle and you're trying to make sure that instead of impacting high on that animal, say taking his spine, you want to make sure that you are actually hitting right on impact, or point of aim, point of impact, and you are disabling that heart. And that's where you need to learn your vertical angles. So one, you have your windage correctly, you have your elevation correct, but also you're doing those formulas in the field within enough time that that animal now isn't going to be walking off and you can't track them. When we discuss transonic ballistic performance, that is basically the performance that is the flight of a bullet as it transitions from supersonic to subsonic. The transonic zone is a turbulent period where the bullet's airflow changes from compressed to uncompressed. This transition can be affected by the bullet's velocity and the speed. Or it can affect the stability and accuracy as well. Also, something that can affect this is the long-range accuracy. You can use a round that says supersonic, but ends up, if you're shooting 1,400 yards, you're eventually going to slow down quite a bit.